Okay, our topic today is 3E, exponential equations. Let's look at what is an exponential equation first. An exponential equation is an equation in which the unknown occurs as part of the index or exponent. This definition means if the variable occurs in the exponent equals something here. As long as the x is in the exponent, this one is called exponential equation. How can we solve the exponential equations? If I can change both of the sides to the common base in 2 powers, this is a logical number sense. If you have 2 powers, they are equal, and they have the same base, so I can ignore the base. Their exponents must be equal. This one is the very important principle for us to solve exponential equations. So let's look at the first example. 2 to the power of x equals 16. So my goal is to change 16 to a power of 2 as well. We can change 16 to 2 to the power of 4. So this is 2 to the power x. So right now I have 2 bases, 2 powers on both sides, and they have the same base. So I can ignore the base. The exponents must be equal. That means in this equation, x is 4. The same idea in this one. 1 over 27. Think about this one is a power of base 3. So I need to change this one to a power of 3 as well. So 1 over 27 is 3 to the power of negative 3. And keep the left side. So right now these 2 powers are equal. I can ignore the base. They are exponents must be equal. So x equals negative 5. The second example, we will have a little bit more challenging exponential equations here. 4 to the power of x equals 8. I found that I'm not able to change 4 to base 8. I'm also not able to change 8 back to base 4 either. But I found both of them have number 2 in common. So I will change 4 to 2 squared, then raised by x, and 8 is 2 to the power of 3. 2 squared raised by x, we can use the exponential rules. This one is 2 to the power of 2x equals 2 cubed. So right now we still have 2 powers on both sides, and they have the common base, which means I can ignore the base. Their exponents must be the same. So I can find the x value by solving a linear equation. The same one. 9 to the power of x minus 2 equals 1/3. I found that I can change 9 to 3 squared. So I change 9 to 3 squared to the power of x minus 2. For 1/3, I will change this one to a power of 3 as well. This one is 3 to the power of negative 1. Then I use the exponent rules. A power of a power, I multiply the exponents. So right now you will find that I still have 2 powers on both sides, and they have the same base. That means I can ignore the base, and their exponents must be equal. So if I want to solve for x in this linear equation, you can open the brackets, but you also can just divide by 2 right away, get -1/2, then I move -2 to the other side, which is -1/2 plus 2. -1/2 plus 2 is 3/2. You can change this 2 to a fraction with 4/2. Okay. So right now, a little bit further of the exponential equations. Solve for x in 4 to the power x plus 2 to the power x minus 20 equals 0. Let's look at, even this one is not to the exponential equation like those cases. I still can see there are 2 powers. One base is 4, one base is 2. If you see different bases in any type of the exponential equations, the first step you guys need to take is always to change both of them to the common base. So I will change 4 to a power of 2, which is 2 squared raised by x plus 2 to the power x minus 20 equals 0. We talk about this one in 3D already. So this one is the same as 2 to the power of x, then squared outside, plus 2 to the power of x minus 20 equals 0. So let's look at which equation we should solve first. If it's very tough for you to see, I can use a substitution method. Let a be 2 to the power of x. I replace 2 to the power x with a. So I can change this complicated looking equation to a much easier looking equation, which is a squared plus a minus 20 equals 0. If you look at this equation, you will know this is a quadratic equation. So the very initial equation actually is a composite equation with exponential form in a quadratic equation. So like those equations, if you use the substitution and replace the power with a single variable a, you will realize I need to solve this quadratic equation first. So we can use factorization to solve this equation. This one is a minus 4 times a plus 5 equals 0. We can get 2 solutions for the quadratic equation. One is 4, and the other one is -5. But my goal is not to look for the a values. My goal is solve for x. What is x? And we know a is 2 to the power x. This time, I plug this 2 to the power x back for a. So I change this a back to 2 to the power x. Or the other one is 2 to the power x equals -5. So right now you will find, okay, with these 2 equations, you are solving 2 basic exponential equations. For the first one, I can change both of the sides to the common base. So x equals 2. But for the second one, we will introduce this one in 3f again. So later on you will know, no matter what the x value here in the exponent for a power, this 2 to the power of x will never be a negative value. So we say this one is a reject. Or you can say the equation should be rejected. There is no solution for this equation. Okay, this is example 3. let's look at example 4. Example 4 is exactly the same as example 3. So for this one, I will change this 3 to the power of 2x to 3 to the power of x squared minus 10 times 3 to the power of x plus 9 equals 0. So if you are not able to handle this complicated looking equation, you can use the substitution. Let a be 3 to the power of x. I can convert this equation into a squared minus 10a plus 9 equals 0. You will find that you need to solve this quadratic equation first. So this quadratic equation can be factored. So this one is a minus 1 times a minus 9 equals 0. So 1a is 1. The other a is 9. The same as example 3, I'm not looking for a. I'm solving for x. So I plug the 3 to the power of x back for a. So this is the first exponential equation. And the second one is 3 to the power of x equals 9. So let's look at if we can change this side to a power of 3. We all know that 1 can be converted to 3 to the power of 0. So right now on both sides, I have two powers and they have the same base. I can ignore the base. The exponents must be equal. The same idea for 3 to the power of x equals 9. I will convert 9 to a power of 3, which is 3 squared. Then I can ignore the base. The exponents should be equal. Therefore, I can get x equals 2. So this is for example 4. Example 5 is a little bit more challenging. I really hope that you guys can pause for a little bit while you are thinking about this question yourself. And after you finish the solving, let's come back to play the video again to look at if you can get to the same solution as what I get. So for me, I will see there are two variables. One is x, the other one is y. Okay. Anyways, my goal is to set up the system of two equations in order to solve the values for two variables. The same idea as all the exponential equations we just talked about in the previous 4 examples. This is a base 16 power, and this is a base 8 power. We need to convert them to the powers with the same base. So we all know 16 is 2 to the power of 4, then raised by x plus 2y, divided by 8, which is 2 cubed, raised by x minus y, equals 32. So let's simplify this equation further. 2 to the power of 4, then raised by x plus 2y, I can multiply the exponents because this is the power of a power. So it's 2 to the power of 4x plus 8y. Then open the brackets, multiply the exponents as well here. So it's 2 to the power of 3x minus 3y equals 32. So you guys know, when I divide two powers with the same base, I can keep the base, subtract the exponents. So 4x plus 8y minus brackets 3x minus 3y. Be careful when you minus them. Make sure you can put down the pair of brackets for both of the initial exponents. So you will see, okay, this is a binomial minus a binomial. When you open the brackets, make sure you can change the sign for the second binomial. So this one will be minus 3x plus 3y equals 32. Okay, so this one is 2 to the power of 1x plus 11y equals 32. Okay, right now on both of the sides, I have one power of base 2, and the other one is 32. And we find that 32 can be converted to 2 to the power of 5. So therefore, on both sides of the equation, I have two powers, and they have the same base. I can ignore the base. The exponents must be equal. So that's how I can simplify the first expression to get to the first equation. I will work on the same one with exactly the same way. So 32 is 2 to the power 5 raised by x plus 3y. Divided by 16 is 2 to the power 4 raised by x plus 2y equals 1/8. For me, I will multiply the exponents and subtract them. So that will be 2 to the power of 5x plus 15y over 2 to the power 4x plus 8y equals 1/8. Subtract the exponents. It's 2 to the power of x plus 7y. And for 1/8, I want to change this one to a power of 2 as well. So this one is 2 to the power of -3. Therefore, you have two powers on both sides of the equation, and they have the same base. Their exponents should be equal. So right now, we will see two linear equations. I want to form them into the system of equations. You learn how to solve the system of equations in Math 10. You can use either substitution method or elimination method to look for what is x, what is y. Here, I will use elimination method because I find 2x, they have the same coefficients. So I minus the second equation from the first equation. So x minus x, they are canceled out. 11y minus 7y, this one is 4y, equals 5 minus -3. 5 minus -3 is the same as 5 plus 3. So this one is 8. Divide both sides by 4, y equals 2. Then I plug y equals 2 back to either of the equations. Let's say this is equation 1, this is equation 2. Let's plug it back to the first equation. So x plus 11 times 2 equals 5. X plus 22 equals 5. What is x? X equals -17. So x value is -17. Y value is 2. Okay, this is the lesson for today.